Okay, so today's question is going to be a simple graph question that could be solved using either DFS or BFS. It's titled, its number is 1466. Its title is Reorder routes to make all paths lead to the city zero. Now, to summarize the question, what we need to do is we've got a graph which is actually a directed tree, so there are no cycles, and we want to be able to go from any node of this tree and reach the zeroth or the root of our tree. Now, since it is directed, there are going to be some cases where the edge is actually going the wrong way, so we need to reverse it. And what we need to return is the number of reversed edges, the minimum number of reversed edges, in order to be able to say that we respect that condition. Meaning we can go from any node towards the root node. Now, if you look at the hints, what's gonna tell you is you're gonna have to keep track of both the edges as if they are undirected and also directed. And we could do either DFS or BFS and visit all the nodes. And whenever we reach an edge that needs to be reversed, we just increment the counter by one. So in order to treat the graph as an undirected graph or undirected tree, we're gonna have to create adjacency lists or adjacency matrix, which is a list of lists equals to collections dot default dict. So in case we don't have the key, it's just gonna create a list, right? And we also need to keep track of directed edges. That's gonna be a set for a b, because we got a I b I in connections. Now we populate the adjacency list. So for the list of A, gonna append B, and since it's undirected, can go both ways. So we do the same for B, append A. Also, since we are the same loop, we just add to the directed edges our A, B directed edge. Now, in order to be in order to stop, we need to stop our loop of DFS. We need to keep track of visited node. So we create a set. Now we define the DFS and call the starting node as n1. We add n1 to the list of our visited nodes. So we got the neighbors. So and I call it nays equals to we use the adjacency matrix of n1, right? And now we need to create our actual counter that we're gonna be returning at the end of our DFS. Now for the conditions, what we need to do is traverse all the for nay in the neighbors in nays if nay not in visited, right? So if it has not been visited, what we're gonna have to do, actually let me write the return dfs and we start at the 0th node, meaning the root. If not visited, what are we going to do? We're gonna check whether or not we will need to reverse our edge in order to increment the counter, right? So we've got if starts from the neighbor to n1 not in directed underscore edges, right? Counter or count plus equals 1. Now the count plus equals the DFS of our nay. Now what's gonna happen is for each and every neighbor, before visiting all the neighbors of a node, we're actually gonna go into the depth, meaning we check the first neighbor of the neighbor of the neighbor, and then we go to the second neighbor and do the same. So we call DFS and then we call DFS again and we increment the counter. Actually here we need to return the counter, which was 0, and this should be called at the end of our DFS. We will return the counter. So let me check this if we got any typos. Directed edges dot add here, right? We're gonna add to our set the directed edge of AB. So this is all good, I guess. Very nice.